and checking label and null value. I removed any unnecessary space in the column name to avoid error during analysis, sorry. I looked at the unique value in the label column to see what type of traffic we are working with, mainly benign and DDoS. Then I check it for missing data by plotting a histogram of null value across the dataset. This give me a quick overview of which features might need cleaning. This is the histogram that I talk about it. After these two steps, visualize the missing data. To get a clearer picture, I created a bar chart showing how many missing value each column had. This made it easy to spot which features needed attention. This is the code of the visualizing missing data in the dataset. And after that, I remove the null value to avoid any issue later. I removed all rows with missing value using the drop now function. After that, I double checked the dataset to make sure no missing value I left. There is no missing value were left. Okay, after that, I handling infinite and non-numeric value. What I mean, I also made sure that any infinite value were treated as missing and checked which column had text instead of number. This is very important because machine learning model work best with numeric data. After that, I checking column type. The label column originally had the words benign and DDoS. I converted this into number. Benign become 0 and DDoS become 1. This make it easier for the model to learn and make prediction. Final step in this stage is visualizing the label distribution, creating histogram to see how many examples belong to each class. This helped me to confirm that the dataset is balanced, which is important for training accurate model. Okay, let's move to data exploring. Before applying machine learning, it's important also to explore and understand the dataset. This step helps us to check for unusual pattern, outlier, or problem, that could affect model performance. I use statistical overview. I started by using df.describe methods that to get basic statistics for each feature. This includes count of value, mean, standard deviation, minimum and maximum value. As we show in the table, count, mean, standard deviation, mean, maximum, and so on for each one of the feature. Here's some of the feature, no all the feature. After okay, this number this number give a quick look at how each features behaves, like whether there are extreme value or large variation in the data. After that, I visualize feature distribution. I need histogram to visualize how the data is distributed. I plotted histogram for each column in the dataset. It helped me to identify skewed features not normally distributed, spot any strange peaks or gaps, understand if value were concentrated in certain range. By combining both the statistical summary and the visual plots, I was able to make better decisions about what features might need normalization or further cleaning before training the machine learning model. Now let's move to data splitting. Okay, once the dataset is cleaned and explored, the next step is to split the data into training and testing sets. This is critical to check how well the machine learning model perform on new unseen data. I split the data into two categories. Sorry, so 70% of the data is used for training and 30% is used for testing. And all of that explain what I'm doing. And now let's move to training and evaluating the model, and this is the most important section in the project. Okay, I use three main models: random forest, neural network, and logistic regression to build an accurate system for classifying network traffic as either benign or DDoS attack. Three machine learning models were trained: random forest, logistic regression, and neural network. The model were trained on the training dataset to learn patterns and the features. I start with random forest. Random forest is an ensemble of algorithms that build multiple decision tree to make accurate and stable prediction. It's good for handling complex data and preventing overfitting. We used the random forest classifier from scikit-learn. The model was trained on the training data, X-train, Y-train, using 50 trees. We then tested its performance by making prediction on the test data. Here is the code of training the random forest. Okay, I visualize feature important. I visualize a single decision tree. We visualized one of the decision tree in the random forest to better understand how the model make decision. This helps us to see how individual trees classify traffic based on specific features. Before the visualizing the tree, I visualized the features, the important features. After training, we used the feature importance attribute to identify the most important features to prediction. We displayed this with a bar chart to see which features contributed the most. This is the bar chart. And after that, I visualize a single decision tree from the random forest. Okay, let's start with the evaluation the random forest model. As okay, the result is accuracy about 99.95%. F1 score 99.95%. Precision is 100%. Recall is 99.90%. The confusion matrix for the random forest model give me four important results. True positive, DDoS correctly predict it's about 10,000 more than 10,000 sorry, record of data. True negative, benign correctly predicted, it's about more than 9,000 record of data. False positive, benign, wrongly predicted as DDoS is 0, and it's very important. False negative, DDoS wrongly predicted as benign,